Hello, my name's Graham Harris and I'm here to talk about the Advanced Mathematics exam for questions 12, 13, 14 and 23 from 2020. So first of all, you can see question 12, it was worth 3 marks and we're finding the sum of an arithmetic series. Now, this question was well done by most of the candidates who attempted it. By and large, it was well attempted. Some of the errors that students made included finding an incorrect value of n when they were trying to find n, and many students actually found n as a value that was not an integer, which should have actually been something they should have picked up, but a lot of students didn't. Some students mixed up their values of a and d, and some students found A and D and L, but weren't really sure how to proceed to find N. So realistically, the recommendation would be for students to set their work out a little more carefully when it comes to questions of arithmetic and geometric series, and to use the appropriate formula from the reference sheet. Going on to question number 13, where we had to integrate. Many students recognise that the integral of sec squared x gives us tan x, which was good. And many candidates were also able to show that they knew they had to substitute some values into their primitive. However, a lot of students worked in degrees mode, which actually ultimately ended up causing errors for them instead of working in radians mode. And some students, instead of subtracting when they were evaluating their integral, chose to add instead. We encourage our students to show the numerical solution when they're doing something like this, not to stop before substituting. Some people integrated correctly, but actually didn't follow it through to a numerical solution for this integration process. Question number 14. We've got a question here where students were asked to draw a Venn diagram or otherwise to find the probability that students study both history and geography. Now, by and large, many students found that the correct value of 5 students that did both history and geography. Many students did good Venn diagrams, some did good two-way tables, and some actually did otherwise, didn't use either of those techniques. But many students didn't have all of their numbers in their Venn diagram or their two-way table add up to 40 students in total. That was a mistake some people made because they had the correct number of 5 for both, but their Venn diagram or their two-way table added up to a lot more than 40 students. Some didn't label their Venn diagram correctly, which ultimately meant they mixed history and geography up. Always good to label your information correctly. The advice for this type of question is to read the question carefully and make sure that what you have drawn reflects the data that the question is providing. We go on to part B. A student is chosen at random. Now, given the student studies geography, what's the probability that the student does not study history? This question was quite poorly answered, really, but those that did get it correct often had correctly labelled Venn diagrams that meant they could get the correct answer. When the Venn diagram was all over the place, it made it very, very difficult for students to get the correct answer. And some students did have the correct answer, but could not interpret the question correctly, which meant that they got the incorrect data somehow from their Venn diagram, resulting in a mistake. Being a 1-mark question, there's not a lot of scope for error. It's pretty much right or it's wrong. And there were students who didn't attempt their question because they didn't understand it or they didn't have information on their Venn diagram or equivalent to allow them to do that. Now, for a question like this, definitely the Venn diagram would be the preference. it was the one that allowed students to have the best chance of accessing their marks in the papers that I saw. Part C, we've got two different students chosen at random, one after the other. Now, with a question like this, many students successfully found the probability of the first student studying history, but the second student not studying history was what they struggled with. Some actually found both successfully, but didn't realise that they needed to multiply the answers together. And some didn't realise that the second student meant that it was a probability question without replacements. So the denominator in the second fraction was not the same as the denominator in the first fraction. Tree diagrams would have been a great idea for this one if needed. It wasn't required, but would have made it easier for them. And again, it's really important that students ensure their answers match the Venn diagram that they provided. We now go on to question 23, which is a question about a probability density function. And this question was well done from the point of view that a lot of the students recognised that it was a probability density function that required some integration. And also many realised that the definite integral had to be equal to 1. Some of the errors was that when they integrated sine x, many students wrote, or not many, some students wrote cos x instead of minus cos x. So that was a mistake that was reasonably frequent. And another common mistake with this one was that students didn't work in radians. They were working in degrees, which ultimately led to errors. The reference sheet contains the correct derivative of the correct integral or antiderivative of sine x, and it's really important that students, if they're not confident with knowing these things off by heart, that they just quickly check their reference sheet. We go to part B, and with part B, many candidates again knew that they had to integrate from 0 to 1 because it said the probability x is less than or equal to 1. Again, students often worked in degrees when they should have been working in radians. I think I've got that around the wrong way, but students should have been working in radians and not degrees. And for our learning outcomes, it was a case of students understanding how probability density functions work. And when you're dealing with the entire integral, if you like, knowing that it's going to equate to an answer of 1. And for this one, going from 0 to 1, we end up with a different type of meaning. So effectively, that is a really quick summation of what we saw, and hopefully you're able to take that away and help apply some of those things to your students in your classes.